Good evening, Titans. And tonight we're going to be looking at graphing linear inequalities and also looking at graphing systems of linear inequalities. A linear inequality is an inequality whose form is like that of a linear equation with the equal sign replaced by an inequality symbol. So if you look, that's a linear inequality, and this is a linear inequality. Notice how they both have inequality symbols instead of the equal sign. And with that, the next definition, a boundary line, as you can see, this would represent the boundary line for that linear inequality. And notice how it's dashed, and we'll explain that later of why that is. And then this would be the linear boundary line for that linear inequality. And again, that's a solid one. And also notice how the two graphs have part of it shaded as well. And we'll discuss those things in the next few slides. There are a couple main things when graphing linear inequalities. The first one is that we have to decide when we're graphing the boundary line whether or not we're going to use a solid line or if we're going to use a dashed line. Now this is all predicated on the type of inequality. If it's a less than or equal to or greater than or equal to symbol, which that's what these are, then we would graph a solid line as our boundary line. But if it's just a less than or just a greater than, then that would indicate that the line, the boundary line, is not part of the solution set. And so we still need to have a boundary to go by for our shading. So we draw an imaginary or a dashed line to represent that. So the first part is to graph the boundary line. And again, that's predicated on whether it's a solid or dashed line on the less than or equal to, greater than or equal to, for a solid line, and a less than or greater than for a dashed line. The next portion of then graphing a linear inequality is to decide how it is shaded. And if the graph is written in slope-intercept form, which will be the recommendation for most of the times when we do this, is that they're written in slope-intercept form, then it's pretty easy to see. If it's a less than or equal to, or a less than symbol, then we would graph below the line. And a slant of the line doesn't matter. It's still going to be below the line. I call it like you're in the attic. You're shading inside the attic. And if you have a greater than or greater than or equal to symbol, as we have below here, then we would shade above the line. So here we have above, here we have above, and I just show that, or think of that as the snow on the roof. So we're shading above the line. Now there is a way that we can test a point to decide how to shade as well, and I'll address that in an example we do down the road here. When we have to graph a vertical boundary line, obviously there's not an above and below of a vertical line, so we have to look at left and right. And just like we did when we were graphing on a number line, if it was x is less than or equal to, or x is less than, we shaded to the left. So for this example, x is less than or equal to a -3. Here's my solid boundary line because of it equal to. And now I'm going to shade to the left. And in the next example, we have x is greater than or equal to, or x is greater than. And so for this one, we have x is greater than a -2. Again, notice how it's a dashed line because of just greater than, but then it's shaded to the right. So again, we have here shading to the right with that example. So if we summarize this, one of the first things we want to make sure we do is to put the linear inequality into slope-intercept form by solving for y. And again, remember that when you're solving inequalities, if you happen to have to multiply or divide both sides by a negative number, we have to remember to reverse that inequality symbol. We have to remember to reverse that. Once we have it in slope-intercept form, then we want to draw the boundary line. And again, solid or dashed. And then we would shade above or below or left or right, depending on the type of inequality we have. So if we look at an example, in this first example, the inequality is already given to us in slope-intercept form. So we're going to go ahead and plot on the graph the y-intercept of a -5. So we're going to go down to a -5 and put a dot at -5. And now we do the slope of 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, and continue that. And we can go down to left 1, down to left 1. And then I'll go ahead and I'm going to use the tool here to make my line. And again, I probably should extend this line throughout my entire graph, but just to kind of show you what we're doing here. And then since this, oops, what did I do wrong? I graphed a solid line, and obviously that's supposed to be a dashed line. So we're going to go ahead and get rid of that. And I'll use the tool here to make that a dashed line. All right. Now, because it is less than, we will end up shading below the line. So below is in this direction. And again, we could use whatever tool we want to use to try to show just a shading below that line. And this represents all the ordered pairs that make this inequality true. We take a look at the next example. We have y is greater than or equal to a -1/2 x plus 3. So again, I'm going to graph my y-intercept first of a +3 on the y-axis. And now because I have a -1 over 2 for my slope, I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. I'll also go up and left, up 1, left 2. Because this is now a greater than or equal to, I'm going to use my solid line tool and graph through my points. And then I will shade, in this case, it's greater than, so I will shade above the line. Now, as I said, if it's in slope-intercept form, it's really easy to look at and decide which way to shade, above or below the line. But there are times where we may want to test a point. And the easiest point to test, as long as it doesn't lie on the boundary line, is the point 0, 0, or the origin. And if I plug in the ordered pair 0, 0 into my inequality, I do that, I have y is greater than or equal to -1/2 times 0 plus 3. I have 0 is greater than or equal to 3. This would be a false. And since this is false, and 0, 0 lies below the line, that means that these must not be solutions below it. So above are the solutions, which again confirms that we must shade above. Now, picking a point to test is always acceptable, But again, if it's in slope-intercept form, we believe that it's just easiest if we look and read greater than, shade above, less than, shade below. Now we're going to look at a system of linear inequalities. In a system of linear inequalities, it consists of two or more inequalities being graphed on the same coordinate plane. Here's an example of one. And the first one given to us, y is greater than and negative x plus 3, is graphed with this blue dashed line, again dashed because it's just greater than, and then it's shaded above. Then y is less than or equal to x plus 2. That would be symbolized with the red line. Again, it's a solid because of the equal to. And then it's less than, so it's shaded below. And if you recognize where those two areas would intersect, would be the blue that's here. So there's our answer to our system of linear inequalities. Now we're going to do one example here. And this is a great example because the second inequality given to us right here is not in slope-intercept form. So that's going to be the first step. I'm going to rewrite this into slope-intercept form. So I'm going to move the 3x over, change size, change sign. So now I have 5y is greater than or equal to a positive 3x minus 20. Again, the negative 20 didn't move, so it doesn't change signs. Now I divide everything by 5. And since I'm dividing by a positive 5, I don't have to worry about reversing my inequality sign. So I have y is greater than or equal to 3/5 x minus 4. And now I'm ready to begin graphing my system. My first one, which is x is greater than a negative 2, well, here's a negative 2 on the x-axis, and then it's just a vertical line. And since it's a just greater than, I'm going to use my tool of a dashed line. And it's greater than, so I am going to shade to the right. So I shade to the right with this. Okay. Now I'm ready to graph my second inequality. This one has a y-intercept of a negative 4. I'm going to go ahead and change that. Negative 4. And then it has a slope of 3/5. So from here I go up 1, 2, 3 over 1, 2, 3, 4, 5. And I can go down 1, 2, 3 over 1, 2, 3, 4, 5. And I'm going to use my line tool again. This time I'm going to use a solid line. And now it's greater than, so I'm going to shade above. Now it's pretty evident where the shading occurs. So my common solution would be in this area right here. And I'll make it a pretty purple here. And that would be the answer to my system of linear inequalities. Now, tomorrow in class, be prepared to be able to graph linear inequalities. When they're given to you in slope-intercept form, make sure you know how to decide whether the boundary line is solid or dashed and how to shade it. And then you'll be expected to be able to use your notes and do a few problems using your notes to show us that you watched the video and you understand the basics of graphing linear inequalities.